Hello and welcome everyone. I'm Ramnath Swami, Product Manager for Performance Analysis Tools in ARM, and in this video I'm going to talk about graphics performance optimization in Android. Before we start, I would like to make it clear who would benefit from this talk. If you're a game developer and if you have one of these problems, like your game overheats the device, or it runs too slow, or it drains the battery of your device, then this talk will be of interest to you. So these are the things we're going to look at in today's talk. Who we are, that is who ARM Limited is, what we offer for game developers like you, and finally, how ARM wants to help you with our various programs. A few words about ARM. We design the vital hardware technologies like CPU, GPU, machine learning processors, etc. Our partners take these components and design chipsets that are used in mobile phones and in many other applications. ARM was established in 1990 as a joint venture between Acorn Computers, Apple, and VLSI Technology. Since then, we grew from strength to strength, and today all sorts of electronic devices use ARM's technology. ARM has shipped over 23 billion CPUs and 1 billion GPUs so far. We have more than 1,000 partners in ARM ecosystem who design various things ranging from chipsets to software tools that are needed for hardware design and software development. And today 70% of the world's population uses ARM's technology. Now that you know who we are, you might have already got some idea about how we can help you. Being the vendor of core technology on which your games run, we are well placed to help you by providing tools and advices for optimizing your games on Android devices. One of the ways we accomplish this is by offering you our performance analysis tool suite called Mobile Studio. Before looking at what Mobile Studio itself is, I would like to give you some background about the problems we're trying to address and the approach we have taken to address those problems. This is the classical approach to performance analysis. One takes the game at different phases of its development, manually measures the frame rate, and if they detect slowdown, then they do performance analysis using the tools available to them. Then, depending on where the problem is, that is in art, game, or engine, one fixes the problem accordingly. This approach works, but it needs key performance analysis expert who understands both the technology and artistic development worlds. There are not many such experts in industry in our understanding, and even if an organization adds such an expert, this methodology is not scalable as it is very time-consuming. Hence, in many cases, performance analysis is not performed as often as needed, resulting in expensive refactoring of the game at a later stage. Also, in reality, the problem is far worse than just a single game title being profiled. Most studios will be actively developing content for multiple game titles concurrently, each targeting a wide range of devices with vastly different performance profiles. A manual profiling approach that is anchored around one or two key experts, again, simply does not scale to this type of mobile deployment. A better solution is needed. Now that we understand the problems we are trying to solve, let's look at a quick overview of the workflow Mobile Studio is built to support. Mobile Studio workflow removes the manual effort and does the analysis automatically. We achieve that by analyzing the profiling information and presenting you the conclusions that would have otherwise taken an expert a long time to come to. Furthermore, we are augmenting that automatic analysis with CI capabilities so you can not only scale it to a large number of devices and games, but also do performance analysis very often. Mobile Studio also points you to knowledge database maintained by ARM, giving you suggestions and advices about how and where to start fixing the issues presented to you. Now that you understand how we are approaching your problems, it is the right time to introduce you to the tools you get in Mobile Studio Tool Suite. It contains various powerful tools to debug graphics issues. Streamline is a system profiler, Graphics Analyzer is an API tracing tool, and Mali Offline Compiler gives you GPU compiled statistics. These tools give you very good insight when you deep dive and analyze your performance problems. But remember, we are trying to automate a large chunk of that analysis work so you don't have to do it manually. Now, to support that, we have launched a tool called Performance Advisor in March 2020. In a few minutes, we will go through the features supported by Performance Advisor in detail. But before that, let's look at the bigger picture and see how you could use this powerful tool in your workflow. The Performance Advisor tool is designed as an analysis engine for data produced by other tools in Mobile Studio tool suite, including event counters captured from CPU and GPU hardware by the Streamline Profiler. And the API awareness is captured by the Graphics Analyzer Interceptor. The basic deployment runs your test application using an API interceptor to provide minimum level of API awareness needed to monitor frame rate. Data is captured for test scenario and distilled into test report, which provides you an overview of the application performance, where the performance bottlenecks are, and the per-frame performance metrics. In reality, games are complex with variable workloads based on where the player is standing, what they are looking at, and what happens to be happening on the screen at that point in time. To provide some level of semantic knowledge to performance reports, developers can annotate their game using simple code markers to break up their test scenario into different regions. With regions defined, the performance report will provide analysis per region in addition to overall summary. The final step is to integrate key performance indicators into your existing test reporting infrastructure. Rather than mandate an ARM solution here, we simply provide per-region metrics, including both averages and frame centile distributions, as a JSON format which can be imported into any non-SQL database and visualized using an off-the-shelf dashboard tool such as Grafana or Kibana. For users following a budgeting methodology, we are yet to have an integrated solution, but budgets can be imported into the same database and used as thresholds against which Performance Advisor data is compared. These usage models of Performance Advisor can be used to do different types of performance analysis that game developers need to perform. We kept in mind these workflows when we designed Mobile Studio and Performance Advisor. The first one is regression testing. This is the most well-known step towards deploying modern continuous integration. In this testing, one gets repeatable gameplay scenario into regular testing and run it automatically for every commit or for every nightly build. Measure and report on key performance metrics throughout development. Track their trends and course correct before problems manifest. By integrating performance testing into regular nightly testing, you also make smaller commit windows to bisect when things go wrong. With this workflow in place, you can save a lot of cost by managing the performance issues right when they occur. The next is budget tracking. This is the next logical step beyond reactive tracking. You proactively set performance budgets in terms of performance metrics like cycles and bytes per frame, or content metric like vertices and pixels per frame, permissible levels of overdraw, etc., and then track current state against those targets. This can be particularly powerful when trying to ensure good performance on older devices or mass-market devices with less capable hardware, as it's much easier to design content to fit those budget points than it is to try and redesign content to fit after the fact. Usefully, you can even set and monitor cycle budgets based on target devices configurations you don't necessarily have access to for live testing. The third one is manual testing. Some degree of manual analysis is always going to be needed, both to solve the difficult problems that automation couldn't and to follow up on reviewing issues that automation has flagged. Even here, the automated analysis can help guide an expert and point out where to investigate further. Alright, let's now look at the all-new Performance Advisor and its features that can be powerful additions to your workflow. This is the initial summary analysis that a Performance Advisor report gives. The most useful initial view is the FPS analysis chart, which helps you answer these important questions without any analysis. Is your game running as fast as it should? Is frame rate acceptable? And if not, where is the bottleneck? It also gives you some advice about where to start debugging. And because you know where the bottleneck is, it helps you know which tool to use next to fix the issue. Performance Advisor helps you answer these questions by giving you this information like frame rate, CPU usage, and GPU usage. It also gives you boundless regions, meaning, for entire capture of your game sequence, it tells you which part of the sequence is CPU bound and which is vertex or fragment bound, and so on. The metrics shown in this chart are per frame metric, and the chart can also show you the slow frame, which is very handy when trying to spot the problem. We were very privileged to have worked with quite a few beta partners who gave some very valuable feedbacks while developing Performance Advisor. One of the most significant additions to Performance Advisor as a result of our beta program is addition of per-frame performance charts. As explained earlier, the underlying data is taken from Streamline Profiler, which does time-based sampling. When these samples are normalized for frame rate, the data becomes much more accessible and relevant. In this example, we can see that GFX Bench Manhattan test running on a mass market device targeting 30 FPS. While some frames manage to hit 30 FPS, there are some significant performance drops which need investigating. Per-frame charts allow a very intuitive means to scan for correlation. If performance always goes down when a particular workload goes up, then there is a good chance that this is a causal factor or secondary effect of one. In this scenario, we can see that the changes in FPS do not correlate at all with changes in primitive complexity, so it is not our performance bottleneck in this case. Whereas in a different chart, we can see that we have almost perfect anti-correlation between FPS and GPU shader cycles, with large drops in frame rate corresponding to large spikes in shader arithmetic cost. This is likely a causal factor. We could now switch across to Graphics Analyzer to hunt down where the problem is. The execution engine is the shader arithmetic processing part of the GPU, so in effect we know that we are now looking for really expensive shader or shaders. Now the FPS chart is shaded pink for parts of the game which do not correlate with shader cycles per frame, which tells us we are likely looking for something which can cause high CPU load. There is a good chance that this may not be visible to Performance Advisor if it's part of the application logic such as physics rather than part of the rendering path. However, in this case we do have visibility of the number of draw calls per frame, which is known to be one of the more expensive operations for the application and for the graphics driver to handle. And we can see clearly that the two CPU-heavy parts of this scene nicely correlate with the parts with highest draw call counts, so draw call counts is the problem for this part of the game. Performance Advisor supports a dedicated lightweight interceptor mode that can monitor performance and inject API calls to generate instrumentation, in particular capturing screenshots for frames which are below target performance. This can be used as a useful follow-up analysis for any game scenario showing performance drops. In this case, we can start to triage the worst-case offenders by rerunning a test case with the interceptor's slow frame threshold set to values sufficiently low to generate some screenshots of specific problem scenarios we want to analyze. For this test case, the workflow automatically generates 3 screenshots which allow us to quickly identify a helicopter as the common element. Subsequent content review using ARM's Graphics Analyzer tool proves that the volumetric spotlight shader is the cause, with a very heavy iterative ray march to determine the object insertion inside the light cone. Note that not all of the slow frames trigger screenshot creation. The interceptor supports a configurable lockout period, which stops screenshot being taken too regularly, so the game stays playable during interactive playtesting. Most games include multiple distinct scenes that need performance analysis, which are expected to have different performance characteristics. For a football game, the content for match selection menu user interface will be very different to the main match play. Within the match gameplay, you may get very different performance for different camera angles, changing from top-down to third-person for a penalty shoot, and changing again for a predefined goal-scoring cinematic. Mangling all of these distinct elements together into a single set of performance metrics is likely to result in data that is inconclusive, so we allow application developers to annotate scenes in their game to provide some level of test scenario decomposition into smaller elements called regions. From that point onwards, performance charts and KPIs are reported separately for each region that is provided. Cost budgeting is a useful exercise to run through, as being upfront about how many cycles, bytes, vertices, and pixels you can afford can avoid a lot of problems later in the development process. In this case, we have set ourselves a target of hitting 60 FPS on a 500 MHz GPU, so we have best case budget of 8.3 million GPU cycles to spend per frame. While some parts of this particular game are under this target, there are definitely regions which are not, and that will need further investigation. It is worth noting that you can do this type of budgeting exercise for devices that you don't actually have access to, although trying to find a close match is always going to give you a more accurate result. In this case, we have set a budget for an entry-level device with a 2-core Mali GPU, but we are running the test application on a higher specification device with 4-core GPU. We have exceeded our cost budget, but the measured FPS shown in green is clearly not dropping for the frames where the budget has been exceeded. This example also provides a timely reminder that correlation is not always same as causation. You can see the GPU cost increase visible as a large increase in shader cycles per frame. So you might initially think to start by looking at what the expense of shaders are. What's more interesting in this case is that the expense also correlates with the step change in the number of pixels rendered per frame, indicating that one or more additional render passes have been triggered for these scenes. Changes in the scene render pass graphs are nearly always very quick to diagnose, both in application code and in tools. So this would be the preferred entry point for debugging this issue. As discussed earlier, the other key aspect of Mobile Studio workflow is its CI capability. We all know that it's good to be proactive when it comes to performance monitoring, but it is expensive if it relies on manual intervention. So Mobile Studio offers CI capability, as stated earlier, to make proactive performance monitoring and analysis easier. Now, let's look at how you move through different tools in Mobile Studio tool suite while detecting and analyzing your performance issues. Since Performance Advisor provides a concise summary of the performance report of your application, it is a great first point of reference. Once performance issues are detected, often one needs a means to deep dive into the issues to find the root cause. Streamline Profiler can give far more visibility of your system behavior and the full set of CPU and GPU counters that are available. It is also a capable native code software profiler if your performance issue is related to high CPU load. For GPU performance issues, Performance Advisor and Streamline can help identify high load on function units or poor content efficiency, but you will need to use tools with API awareness such as Graphics Analyzer and Mali Offline Compiler to get visibility of the API calls and shader programs costings. Now a few words about the rest of the tools in Mobile Studio tool suite. As briefly mentioned earlier, Streamline is the system profiler that you get in Mobile Studio's tool suite. Streamline has visibility of the hardware resources like program counter and event counters and can display them in the timeline view as shown in the upper half of the center window. It can also import events from OS and display them in this timeline, which helps you understand where your CPU and GPU spend most of their time. Once you have spotted a problem, you can easily drill down to the part of the source code which is related to the problem using Streamline. Streamline's call path view is also widely used to find code hotspots by many users. Streamline also supports various types of annotations which are carried forward to Performance Advisor, so you have a consistent view of the app in both tools. Obviously, more information about Streamline can be obtained from its user manual and other dedicated contents. Graphics Analyzer is an API debugger which can show the API state after every API call. It is a great tool to understand the root cause of rendering errors and identify the sources of rendering inefficiencies. Again, more information about Graphics Analyzer can be obtained from its user manual and other dedicated contents. Now that we have seen the features of Mobile Studio, I would like to give you some clarity about different editions. There are two editions, Starter and Professional. The Starter edition contains all of the features that ARM offers, including Performance Advisor. It is a free tool and can be downloaded already. Professional edition is a commercial tool and comes with CI capabilities and official ARM support on top. This tool is planned to be released in summer 2020. You can download Mobile Studio Starter Edition for free today by scanning this QR code. And if you're interested in Mobile Studio Professional Edition, then express your interest in the web form this QR code takes you to, and we will get in touch to give you access to the tool. Before we wrap up, I would like to give you a brief idea about ARM strategy to help game developers. First of all, as a leader in mobile hardware technology, ARM would like to make performance accessible to every developer. We wanted to create a platform for us to reach out to developers, not just with our tools, but more importantly to spread the wealth of knowledge we have about our hardware. Secondly, we would like to provide a solution to organizations that are intending to proactively do performance analysis in a large scale, that is on large number of devices and across large number of developers. Thirdly, we would like to provide ARM hardware-specific performance information inside game developers' choice of development environment, and also provide you the means to transition between the development tools seamlessly. And the way we achieve this is by offering the Starter Edition to make sure everyone has a solution free of cost. And those who want to do larger scale performance analysis have the Professional Edition with which they can develop CI workflows to proactively monitor and analyze performance. And thirdly, Unity and ARM are exploring the possibility of giving better profiling experience for Unity customers. We are currently interviewing several Unity customers to understand how they want us, Unity and ARM, to add value together. This may include providing smoother transition between Unity and ARM tools and providing information of one tool inside the other in the future. Thanks for watching. You can get many more useful content from our website, and we wish you great success with your graphics optimization.